In this video, we're going to take a look at the parallelogram with all of its properties. Now remember from middle school that what makes a parallelogram is that it has exactly two pairs of parallel sides. And there are lots of quadrilaterals out there that have two pairs of parallel sides. For instance, a rectangle has two pairs of parallel sides. So it is a parallelogram. The rhombus has two pairs of parallel sides. So it is also a parallelogram. The square has two pairs of parallel sides. So it is also a parallelogram. So there are a lot of different types of parallelograms in the world around us. Some things that you need to be aware of that all parallelograms have in common is that they all have four sides and four angles. The sum of their interior angles is always 360 degrees. And you don't need to know that the sum of the exterior angles is always 360. So those are properties of all quadrilaterals, but some additional properties that parallelograms have going for them is that they have both pairs of opposite sides parallel. We talked about that a little bit already. And again, the reason squares, rectangles, and rhombuses fall in this category is they have both pairs of opposite sides parallel. A parallelogram has both pairs of opposite sides that are congruent. So in the picture, notice that the top side is congruent to the bottom side, and the left side is congruent to the right side. Notice too that these sides that are congruent to one another are the sides that are opposite. Another property of the parallelogram is that they have both pairs of opposite angles that are congruent. So again, notice it says both pairs. So opposite angles would be the angles in the upper right and the lower left. Those guys are going to be congruent to one another. And the upper left angle is going to be congruent to the lower right. So again, both of those pairs of opposite angles are always going to be congruent. Another property that you should be aware of regarding the parallelogram is that it has consecutive angles that are supplementary. Sometimes these consecutive angles are known as adjacent angles. And really, if you remember your properties of parallel lines, it'll make it very easy to remember this property. If I think about taking and extending the top side of my parallelogram and the bottom side of my parallelogram, then really those supplementary angles are angles that would be same side interior angles along those red parallel lines and that yellow transversal. And remember that when lines are parallel, same side interior angles are always supplementary. So those guys would be supplementary. The green angles would be supplementary. The purple angles would be supplementary. Any two that are adjacent, meaning next to one another, would be supplementary angles. The next property is that the diagonals of a parallelogram bisect each other. So in other words, the two pieces of the red diagonal, here and here, are going to be congruent to one another. And likewise, if I draw the other diagonal, that purple one, its two pieces are going to be congruent to each other as well, due to the fact that the red diagonal bisects the purple diagonal. And the last property that you need to know is that the parallelogram has diagonals that divide it into two congruent triangles. So in other words, the yellow triangle and the purple triangle in that picture would be congruent to one another. So these properties are really nice and all that, but what are you going to use them for? Well, we might use them to solve problems involving algebra. And my favorite, and I'm sure it will be yours also, we might use them to write proofs. So because we're using these properties both to problem solve and to write proofs, it's important that you be comfortable and familiar and know all of them very, very well. All right, up on the top of the back page, let's take a look at how we might use some of these properties to solve problems. In number 1, it says two diagonals meet at point T, and they're drawn in parallelogram HJES. Notice this little symbol, or this little parallelogram-y looking symbol, really stands for parallelogram. It says the length of HJ is 11. The sum of the total lengths of the diagonals HE and JS is 38. The length of HT is 8.5. How can we use the given information to find the length of JS? The first thing that I'm going to do, because they haven't provided us with one, is to draw a picture. So in parallelogram HJES, one important fact to notice is how we name the vertices of this parallelogram. Take a look at the order in which they're named. I can either go around my parallelogram in clockwise motion, and notice that if I do that, points H and E are opposite from one another, as are points J and S. Or I can go around in counterclockwise motion, in which case, again, notice that H and E are opposite and J and S are opposite. So it doesn't matter whether you name those vertices clockwise or counterclockwise in going around that parallelogram, but you do need to do one or the other. You cannot make H and J opposite and E and S opposite. J has to be opposite from S, just like E has to be across from H. That's really important. So we've got the first diagonal in there, HE. I'm going to make that one blue. The second diagonal is JS, and I'm going to make that green. It says the sum of the two together, HE plus JS, is 38. And it tells us the length, or the distance between points H and T, and remember point T is right here in the middle, is 8.5. So if I know that the distance between H and T is 8.5, and I know that the diagonals in a parallelogram bisect one another, I also know that the distance between T and E has to be 8.5, or the length of all of the blue diagonal is 17. So the distance from H to E is 17. So I'm just going to come back up here and plug this into my equation. 17 plus whatever the length of JS is has to be equal to 38. And now when I subtract 17 from both sides, I find that the distance between points J and S is exactly 21. But again, there were a lot of properties I needed to know. I had to know about naming those points as I go around in a counterclockwise fashion. I had to know that the diagonals in that parallelogram bisect one another. So again, a couple different facts I really had to have straight in my mind before I was able to solve that problem. Number 2 says in parallelogram TREN, a diagonal is drawn. The measure of one of the angles is 66, the measure of a different angle is 63 degrees, and they want us to find the measure of angle RNT. So I'm going to start the same way as I started the last one by going ahead and drawing that parallelogram and naming its vertices. I like to go around in a clockwise fashion, but you could go around in a counterclockwise fashion and it would be just as effective. And we're going to draw in there that diagonal that lives between points R and N. I could, if I wanted to, draw in the other diagonal, but in the interest of trying to keep this picture as simple as I possibly can, I'm going to kind of hold back on drawing that other diagonal in for the time being. If I need to, I can always go in and put it in later. So let's go see what else we have to label in this picture now. This says the measure of angle REN is 66 degrees. So angle REN is this guy down here. And the measure of angle RNE is 63 degrees. So this guy here, 63 degrees. And they're asking us to find the measure of angle RNT. So they're asking us to find this little one in here. That's the fellow I'm searching for. So I can think of, off the bat, a couple of different ways that I could solve this problem. The way I'm going to start is I'm going to start with the angles in that yellow triangle. I know that the angles in that yellow triangle together have to add up to 180 degrees. So I'm going to take my calculator now and I'm going to subtract the 66 and the 63 from 180. And when I do that, I find that the missing angle in that yellow triangle is 51 degrees. I also know that in a parallelogram, the left side and the right side are going to be parallel. And when that parallel line, or when those parallel lines are cut by a transversal, I know that the alternate interior angles that are formed are going to be congruent to one another. And therefore, since my little purple angle that I'm looking for is alternate interior to that 51 degree angle, I know that the measure of angle RNE is going to have to be that, RNT is going to have to be the same 51 degrees. So that's one possible solution. I've also seen kids use the fact that consecutive or adjacent angles together have to add up to 180. So again, this time if I'm using the same two parallel lines but this green transversal, they'll say, well, this green angle plus the green angle I just did with two arcs have to be supplementary, so I can do 180 minus the 66, and that has to be angle ENT, and then subtract the 63 that already lives at that angle from that difference, and you end up with 51. So again, a couple different approaches, both of which are correct, but just use different properties of the parallelogram in order to solve them. All right. I do want you to, now that the video is at an end, take a few minutes and see if you can summarize the important facts, the important key ideas from this video down at the bottom. And as always, thank you for the gift of your time and watching. And please remember that if you have questions, I'm happy to answer them when you come back to class.